Hey there guys, Mr. Posky here. Hope you're having a good day so far. We are doing 2.7 today, which is division of real numbers. Our essential question is, how do we divide real numbers? So we have a warm-up here, and why don't you guys go ahead and give the warm-up a try, and then we'll go over it in a second. Alright, so the warm-up says 8 divided by 2. Super hard problem. What's 8 divided by 2 going to be? That's going to be 4. Perfect. Now, what is 8 times 1/2? What is half of 8? It's going to also be 4. Nice. Now we have 12 divided by 4, which is going to be what? It's going to be 3. And what is 1/4 of 12, or 12 times 1/4 is going to be also 3. So we'll come back to this in a second here, but what changed? What is the relationship between 2 and 1/2? We changed it from division to multiplication, and we changed it from 2 to 1/2. Well, if we put 2 over 1, what is 1/2 in relation to, what is 1/2 in relation to 2 over 1? It's going to be the, starts with an R, it's the reciprocal. So the whole point of this lesson is dividing by a number is the same thing as multiplying by its reciprocal, okay? So perfect, you got the name of what's going on in the lesson already, you're good to go. So reciprocal just means we need to flip the numbers. So we had 3 over 5. What's the reciprocal of 3 over 5? We flip them, we're going to get 5 over 3. Go ahead and try the rest of them on your own. All right, welcome back. We got negative 17 over 1. So negative 17 over 1, it would be actually, I guess it would be 1 over negative 17. But our negatives usually float to the top. So this is actually going to equal negative 1 over 17. Okay, we don't usually leave the negatives in the denominator, okay? So the reciprocal, even though the negative's on the top here and it's still on the top from where it was, that's totally fine. The reciprocal negatives don't usually stay in the denominator like this, okay? Let me cross it out. We're not going to leave it like that. We're going to go like negative 1 over 17. All right, number 3, we have 7. Well, it's a whole number. So every whole number you can put over what number? You can put it over 1. So 7 over 1 becomes 1 over 7. All right, last one's kind of tricky. Ooh, I'm freaking out a little bit here, guys. I'm freaking out. We got negative 2 and 2/9. Well, I need the reciprocal of this, but the first thing I need to do is convert it to an actual improper fraction. So how do I do that? There's a couple things we do. We do multiplication and addition. Or are we going to multiply? Well, we're going to multiply negative 2 times 9, and then we're going to add 2. Actually, you're going to kind of ignore the negative until you get to the very end. Keep the negative along for the ride, but don't like do 9 times negative 2 and then add 2. That's not going to be right. You're going to kind of ignore this for now, and you're going to just do 9 times 2, which is 18, and 18 plus 2 is 20. So we're going to get, this is going to be equal to negative 20 over 9. So when you have negative mixed numbers, the negative, don't like add the negative into your calculations here. But basically, you multiply the whole number times the denominator, and then you add the numerator, and you get our mixed number, or our improper fraction here. So if we had negative 20 over 9, we flip that around, we're going to get negative 9 over 20. It wouldn't be 9 over negative 20 because we keep the negatives on the top of the fraction usually. Okay? So like I kind of gave away the warm-up a little bit. Probably shouldn't have done that. You can also think it through a little bit. But the rule is dividing is the same thing as multiplying as what? As multiplying by the reciprocal. Dividing is the same thing as multiplying by the reciprocal. Okay? And what you need to know about multiplication and division is that their rules are the same, basically, when you're multiplying positives and negatives, right? So what were the rules again? If I multiplied two numbers with the same sign, if I did like negative 3 times negative 2, is that going to be a positive 6 or negative 6? That's going to be positive 6. So same thing over here. Dividing two numbers with the same sign, we're also going to get a positive. What about when we multiplied two numbers with different signs? If we did like 7 times negative 4, that's going to equal positive 28 or negative 28? That's negative 28. So same thing for division. They're going to end up being negative if they have different signs. Okay? All right. So it says choose your own adventure. Why don't you guys go ahead and give these a try. Just remember, if you have a weird thing like you're dividing by negative 1/4 or you're dividing negative 2/3 by 5, you can multiply by the reciprocal. Multiply by the reciprocal. You're going to flip it and multiply. It makes it easier to do. But try to just divide it if you can. Give them a try and then we'll see how we do. It's kind of hard stuff, but do your best. All right, welcome back. So, negative 34 divided by 2. Let me just check something really quick here. Yeah, so that's just going to be, I would just divide this. I wouldn't do the reciprocal thing. I would just put negative 17 for our final answer. Okay, now number 2 is a little tricky. We're dividing by a fraction. So remember, it's dividing fractions easy as pie. Flip the second and multiply, or keep, change, flip. So I guess I should have mentioned that from the beginning of this lesson, is that the keep, change, flip and dividing fractions easy as pie, flip the second and multiply, the fraction wrap. It's doing the dividing is the same thing as multiplying by the reciprocal. So we're going to keep, we're going to change, we're going to flip. I'm going to actually break the 10 over 1 though. When you do this, I would put the original number over 1. So dividing fractions, we flip it and we multiply, okay? So let's multiply straight across now. Negative 10 times negative 4 is going to be 40. 1 times 1 is going to be 1. We get, our answer is going to be 40. Okay, so instead of dividing by negative 1 4, which is like, what do we do with that? We just flip it and multiply. We flip it and we multiply. All right, number 4 is pretty tricky. We got negative 2/3 divided by 5. Well, it's just kind of weird because it's written like this, but this is 5 over 1. This is actually negative 2/3 divided by 5 over 1. And so we can keep, change, flip, or flip the second and multiply. Negative 2/3 times 1/5. And multiply straight across. We get negative 2 times 1 is going to be negative 2. 3 times 5 is going to be 15. Okay. All right, number 5, 30y divided by negative 2/3. So I'm going to write 30y over 1, and I'm going to change, keep, change, and flip. Negative 3 over 2. Now, when we are multiplying fractions, we can also do some canceling. I don't know if it's called the butterfly method someone mentioned, but you can reduce or cancel vertically, up and down, or you can reduce or cancel diagonally, like this. Okay? And so, can we reduce vertically 30 and 1? No. 3 and 2 is our number that goes into 3 and 2 nicely? No, those are both prime numbers. What about 30y and 2? Yeah, they're both even numbers, so any even number is divisible by 2. So well, how many times does 2 go into 30 going to be? That's going to be 15. And how many times does 2 go into 2? That's 1. So our new problem is going to be 15y over 1 times negative 3 over 1. You can multiply straight across now. That's going to be what? Negative 45y over 1, or just negative 45y. Okay? But you also could have just multiplied straight across. You would have gotten negative 90y over 2 if you just multiplied 30 times negative 3 and 1 times 2, which would also reduce to negative 45y if you did that right. Okay? So you don't have to reduce or cancel, but it does help with some of the bigger numbers when you're trying to do mental math and stuff. All right, number 6, negative 81x plus 18 all over negative 9. Well, a property of fractions is that if you have 2 terms, remember the terms are separated by addition signs, 2 terms in the numerator over the same denominator, you can split them up. So I'm going to split this up into negative 81x over negative 9 plus 18 over negative 9. It also goes the other direction. You can take, if you have the same denominator, you can combine these into this top part right here if you wanted to. But it's easier just to split it up here. So what's negative 81x divided by negative 9 going to be? That's going to be 9x. And what's 18 divided by negative 9? That's going to be negative 2. Are these like terms over here or no? They are not like terms. They do not have the same variable, same exponents. That's going to be your final answer for this one. Okay, so reminder about the inverse property of multiplication. Inverse property of multiplication. The product, which is what operation? That's multiplication, right? The product of a number and its reciprocal is 1. The product of a number and its reciprocal is 1. So, for example, if we did 5 times 1/5, that's just going to equal 5 over 1 is going to cancel. We're going to get just 1. And if we did negative 1/7 times negative 7 over 1, which you negative floats to the top, that's also going to be just 1. Okay? So that's kind of the inverse property of multiplication. When you multiply by the reciprocal, it just goes to 1 because they cancel out. It's like you're dividing 5 by 5 here, and you're dividing 1/7 by 7 over 1. Okay, we're cruising along, doing a great job here. All right, this next section is important, and people tend to struggle with it, but it's really, if you stick to how I'm explaining it here, you're not going to be too confused, okay? It's just kind of weird, but don't panic, okay? We're going to be okay. So finding the domain. Domain, was that the input or the output of a function? Do you guys remember? Domain was the input. And was it X or Y was the domain? It was X. Okay? So domain is the input or X values, and we can't divide by what number? What number can you never divide by in math? 0. Okay? So we're going to combine that information together here. It's because we cannot divide by this number, this is called a domain restriction, and it will mess up our function. All right? To find a domain restriction, we need to find what makes the denominator only, I'm going to put only down here with 3 exclamation points, only the denominator equal to 0. Okay? So let me explain what we're talking about here. Okay, we have this function, it's y equals 7 over x. So if I made a table, an x, y table, don't write this down right now, just kind of follow along here, okay? And I plug in -1, 0, and 1, right? Okay, let's plug in -1 in for x. Well, I plug in -1 in for x, we're going to get 7 over -1, which is -7. But if we plug in 0 in for x, what's 7 divided by 0? That's undefined. Okay? And we plug in 1, we get 7 over 1, that's also going to be 7. Okay? So what we're looking for, we're going to set the denominator equal to 0 because that's what's going to cause these undefined problems when we have 0 in the denominator. Okay? So the domain, what this is asking, it's saying what can we plug in for x that will work and what will not get messed up. And what messes it up is when we have 0 in the denominator, okay? So the trick to figuring this out is all you're going to do is you're going to literally, every time you do this, just don't do anything different here, okay? People try to set the top, people try to do like 9x squared. I'll talk about that in a second here, but you're going to circle the bottom, you're going to cross off the top, and you're going to take the bottom, whatever it's equal to, and you're going to set it equal to 0. Okay, this one's an easy one because there's nothing to do to solve for x. X is already solved here, right? So the answer for this one is what would make this a problem, like we showed in that table that I drew there. When x equals 0, we had an undefined value because you can't divide by 0. So the domain, it can be this double R like this, is all real numbers except 0. So what this is saying, the domain is saying that say you can plug in any number you want for x on the number line, because that's what real numbers means, is any number on the number line, and except for 0. So what we're going to write for our final answer is we're going to do a double R. So that means x can be any real number. It could be pi, it could be -1/2, it could be 17 million, any real number you want. But the problem is, for this function, is when you set x, we're going to put x cannot equal 0. Okay? This is what the domain can be. It can be any real number you want it to be, but it cannot be 0. All right? And that's all you got to do. That's a domain restriction. Okay? It's just any number that makes the denominator equal to 0, and then you just put the double R in front for saying it can be any number you want. It can be all reals, but x cannot equal 0. Okay, this is tricky for you. Don't panic. People struggle with this every year, but I can't stress enough how it's really pretty simple just to solve. You take the bottom, set it equal to 0, and then you write the double R. It can be any real number it wants. You can plug in any number you want for x in this function, the y equals 7 over x, and it will work, but it will not work at x equals 0. So you have to put x cannot equal 0 to keep it from messing up on your calculator and stuff. Okay? Let's do a couple more here. So now the next one we have y equals 9x squared over x plus 4. Well, same thing. We're looking for what makes the denominator equal to 0. Not the top. We're going to circle the bottom here. People try to do this all the time, and it really frustrates me. They go like that. We don't care about the top. The top doesn't matter, okay? The top does not matter. That will not make a domain problem. What makes the domain a problem is the denominator when it equals 0. So don't be setting the top equal to 0, okay? You're going to do the bottom, which is x plus 4. Set it equal to 0, and then you're going to have to solve or think it through. So what number plus 4 is going to equal 0? Well, hopefully you can guess it's going to be -4, or how would we solve this if we were going to solve it? So if we were solving x plus 4 equals 0, we would do -4 from both sides, right? So the answer is, what would make this denominator equal to 0 is -4. So our answer, the domain can be all real numbers, a double R, except -4. So So we're going to do, our answer we're going to box is it can be all real numbers. The domain is all real numbers, but x cannot equal -4, okay? And then make sure you put the do not equal. This is what's saying what would make the denominator equal to 0, but what we're trying to say is what it can't be. So it can't be equal to -4, and that's our final answer, okay? So when we solve it, that's what makes it equal to 0, but this is what the answer is when you do x cannot equal -4. Okay, so if we did an example, we were making an xy table, we plug in -4, so we get 9 times 4 squared, so it's 9 times 16, which or whatever that is will be on top. And then we have -4 plus 4. We plug that in, you're going to get something over 0, and that's a problem, okay? So that's why it's a domain restriction, because it'll make this denominator equal to 0. All right. Get rid of those. Okay, cool. One last example. Why don't you guys go ahead and try this last one on your own and see how you do, and we'll go through it in a second. All right, we got a really complex thing on the top, but like I said, I don't give any care about the top. I do not care about the top. I only care about the bottom. So we're going to take the bottom, we're going to set it equal to 0. Oops. If we solve for this, we can add 8 to both sides, or we can just guess what number it would be. So x equals 8 is going to be our problem. So we can do the answer is all reals except 8. So we're going to do a double R. We're going to put x cannot equal 8. That's our answer. The domain can be any real number we want, any number on the number line, but it cannot equal 8 because 8 would make it 0 in the denominator, and we do not know how to divide by 0 in math, and that's why it's a problem. And that should be the last of the lesson for today. Thanks for watching. Have a great day, and we will talk soon.